Hello and welcome to another episode of Ken's Training, and today's training is going to be on performing an annual service to a split air conditioning unit. Behind me is the UPS room, and there are 4 air conditioning units in there, 4 separate units, and 4 condensers in the garage area of this location. It's a little loud in there, so I want to do the intro out here before we go in. So there'll be a little bit of noise when you hear the video, background noise from the UPS. It makes a lot of noise, and I cannot control that. So we're going to be washing down the evaporator coils, changing out the air filters, washing the evaporator and condenser coils, and stuff like that. So we'll go inside and we'll show you what's up. Okay, so the video that we're going to do is going to be on this air conditioning unit. We call it number 4, AC number 4, and it's a 4-ton unit. The thermostat is here on the side. I dropped it down to 65 just so I could make the compressor work. And then I monitor the temperature right here of what the output is and what the room temperature, or what the into the evaporator temperature is. So into the evaporator is at 70, and it's supplying 58 degrees Fahrenheit. That's telling me that we're getting like about 11 degrees Fahrenheit of a delta T, which is pretty good. Not a bad delta T. This is a carrier unit. This is the data nameplate. It's R22 is the refrigerant, and this is 208 volt. So just an overall, I'm just giving it an overall inspection before I go ahead and shut it down. So I'm going to go ahead and shut it down by the switch over here, and that's going to shut it off. And then what we'll do is we'll also shut the breakers off, and then we'll try to turn it back on, verifying that the electricity is off. And then we'll start the service on this. Alright, we've got the electricity off at the breaker and at the switch, and it's confirmed off. Now we're going to open up this door right here. I got a 5/16" hex head bit, and there's just a few screws here. But you can come over here and you can take a look at the coil. Okay, so this here is an A-frame coil. It's pretty dry, telling me it doesn't get a lot of moisture into here, but I'm going to go ahead and spray the coil down with this Hudson sprayer. And I'm just going to go ahead and just try to wash that coil up a little bit. Once I've washed that down, there's also a condensate pump over here. So we'll give that a good flush of water and make sure that that condensate pump is working really well. So we're going to go ahead and do this right now. So in the process of washing the coil down and testing out the pump, what's happening is if you zoom inside here, you see that we got a lot of water in the tray. And the tray is not draining down, so it looks like this is clogged up. So we're going to try to clear that clog right now to get that water out of the tray. So that's where we're at right now. Okay, so what we've done is there was a couple of screws holding this plate in. I took that off. We took out the condensate pump, which here's what is the underside of a condensate pump if you've never seen it. So what happens is this is the base right here. What normally happens is as the basin fills up, it brings up the float and hitting the switch, which turns on the pump and then pumps it out the discharge. And there's a little check valve right here. And that's basically how it works. I tested it off in the garage to verify that the pump is resin, and I just put it underneath the drain line here, and just added some more water with the Hudson sprayer, which is right here, to try to clean it out. The way that this is piped in, it's so level that you really have to put a lot of pressure, a lot of water. The water level has to come up fairly high before it begins to drain out, but it does drain out. I'm going to go ahead and turn the shop vac on and clean out this pan. Shoot it up there before I brought the shop vac down, just to clean it out really good as well. So we're going to basically button this all up because there's not much that we can do. One thing you can notice on the inside is that there's no TXV. The liquid line is right here, liquid line for the refrigerant. It comes into right here and it goes through a distribution. And then there's 4 capillary tubes right here. These 4 capillary tubes go to 2 on this side of the A-frame coil and 2 to the other side of the A-frame coil. The refrigerant goes up the evaporator, vaporizes off into a gas, and then here's the suction line here back to the compressor. So basically, we're done inside the evaporator section. I'll vacuum that out one more time, put my panel doors back on, and screw everything back together. Okay, so what we've done is we removed the access panel that's now exposing the supply fan blower motor, and I can see the top of the A-frame coil really well. I changed out the air filter and put in the air filter going in the correct way. The airflow travels up and out of this unit. So the metal should be facing up. They also give you arrows, like right here, that let you know what the airflow should be. The airflow is going up. And then I also, when I put an air filter in, I put a date on the air filter, the date of installation, so you know when it's installed. Now, the air filter is in. Actually, we'll leave it out for a minute. And just put some safety glasses on. And I'm going to take some compressed air. And I'm going to turn the blower wheel, the squirrel cage blower wheel, and I'm going to just clean it. And same on the other side. Just trying to blow it out and clean it. I'm also going to take it and clean the A-frame coil a little bit. So if my Hudson sprayer didn't get it, because it was kind of weak, a Hudson sprayer is not a lot of pressure. This is 100 pounds. So this is good pressure. I hit it off camera a little bit, so I spent a little bit more detailed time, but I'm just trying to give you the demonstration so you can see the steps that I'm taking to perform the annual. So I've cleaned out this here, cleaned out this here. Now let me just give you a little bit of a general overview of what's happening on the inside. We'll reposition the camera. Alright, so now I just want to demonstrate a little bit about the internal workings of this particular evaporator section, of the split section here. So the electricity comes in here on these 2 lines. This particular a capacitor, this device right here. There's no bleed resistor across these terminals right here. So if I want to work on that capacitor, you need to short it out. I'll just throw some safety glasses on, take a pair of needle nose pliers, and then touch it in between this leg and this leg simultaneously. So if there's a static charge still in the capacitor, it will short itself out in discharge. Alright, this particular one did not have a static charge, but whenever you kill the power, this is the one component that potentially can still have a static charge of 30,000 volts and can still take your life. So you just want to be aware of that. And that's the procedure to discharge it. Basically, we are completely done on this section of the manual. We're going to put this door back on right now. Okay, so right here is condenser for number 4, this split system that we're working on, 4-ton unit. Now, this condenser is a pretty good distance from the UPS room, but it does have a liquid line right over here. This liquid line is showing me absolutely no bubbles in the liquid line, indicating that from here going all the way back to the evaporator is a full head of liquid refrigerant, indicating there's not a loss of charge here. Now I've got a sheet here that I'm going to fill out, which is just basically telling me the health of the unit. I'm going to get some pressures, not pressures. Basically, I'm just going to get some temperatures. And the reason why is because at this point in time, I see no reason to even put my manifold gauges on the unit. It looks like it has, if anything, overcharge, not an undercharge. So the first thing I'm going to do is I'm going to check the data nameplate for how many amps the compressor and the condenser fan motor are supposed to pull. So the data nameplate is over here, and it says the compressor run load amps is 7.7, the fan is 0.7. So 8.4 amps is pretty much the full load amps of this unit. So what I'm going to do is I'm going to take my meter and I'm going to put it on amperage, and I'm going to see how many amps it's drawing from the disconnect behind me. Alright, so here's the disconnect switch for number 4. I'm going to open that up, exposing the fuses. The electricity comes in the top through the fuses. The knife switches are right there, which you disengage and engage depending upon the throw of the switch. I'm going to take this, put it on amperage, push my backlight, and see if you can see it. Alright, so that's phase number 1, well phase A, is 6 amps. Phase 2, it's easier for me to grab it up here. It's about 5 amps, 4.65. Phase 3 is about 6 amps. So this compressor is not stressed. It's not stressed on amperage. It's got enough refrigerant inside of it. There's not even a reason to put manifold gauges on the unit. I'm just going to go ahead and get some temperatures utilizing my field piece right here. I'm going to use this to get the temperatures of the air going in the condenser coil and out of the coil. I'll write that down to get a delta T, and I'll do the same thing with the evaporator, and I'll write a few things up, and then I'll get back to you. Alright, I should point out that I'm also going to take a garden hose with the spray nozzle, and I'm going to completely wash this coil after I'm done. I don't want to do it right now because I still got 3 more units to go, and I don't want to be walking in a whole bunch of muddy water or dirty water right now. The last thing that I will do after everything is all done, is I will wash all the coils down at once, and all my equipment will be away so that it's I try to stay as clean as possible. So that's one thing that we're going to do here. Now I did get some readings on the condenser. The inlet temperature is 79 degrees. The outlet temperature is 94, providing a delta T of 15 degrees Fahrenheit. So the temperature difference across this coil, the condenser, is 15 degrees, telling me that this is working pretty good. A 15 degree split is a good split. I'm satisfied. I'm very happy with that split. The compressor is not stressed. I got no bubbles in the sight glass. Everything looks really good. We're going to go check out the evaporator. Okay, so we're back at the evaporator section of the split system. Now, even though I have my own thermometer on this unit, I want to use the exact same thermometer that I used at the condenser, because if there's variations in the two thermometers, I want to be as consistent and accurate as possible. I should note that on my meter, Fieldpiece SC77, when you want temperature, you put in this adapter right here, and you put this at 400 degrees Fahrenheit. There's two prongs here, one's fatter than the other. The fat one goes on the right-hand side. They call it a Type K thermocouple. So that goes in there, and then at the end of the thermocouple right here is where it reads the temperature out here on the display. So using this meter, I was able to get the evaporator inlet and evaporator outlet temperature. The inlet temperature was 72 degrees and the outlet temperature was 57, giving me a delta T of 15. Well, that's a really good delta T. I'm getting 15 degrees efficiency across this old coil right here and across this split system. So all I have to do that's left is just simply wash down my coil on the condenser just to get the dust off, and this annual is completed. We're going to just do the same thing to the other 3 units in here, and then we're completely done. And, so here we are in unit number 1. The other one was unit number 4. We took the panel doors off. You can see that this one is a little bit different. The vintage must be a little bit newer. The coil is no longer an A-frame coil. It's just a slanted coil. Let's see, the motor here is mounted differently as well. And what else? There's no PC board, and the way that they built it so that I can take out this panel door without it interfering with the suction and discharge lines. I mean the liquid line and the suction line. Basically, all I did was just put my safety glasses on, took some compressed air, and I'm cleaning the blower wheel, cleaning the coil as well. I'm going to take out the air filter and change that out. One thing that I want to do, alright, so one problem I was having with this unit is that the air filter kept getting sucked up into the coil. The fan is pretty powerful. So I put an extra bar in here. This bar, you can see how it kind of kept that air filter tamed into place and prevented it, from sucking up into the evaporator coil. So I just wanted to show that out. We're just going to go ahead and continue blowing this out and cleaning it out. Alright, so here we are washing the evaporator coil out. Just to show you that, just using the Hudson sprayer and spraying the coil down, trying to clean that out. Also, what that will do, in addition to cleaning out the coil, but it will also give us the opportunity to flush out this line right here. That line is the drain line, the water drain line from the coil. So we're going to flush that out as well. Okay, so what we've done is I've taken the thermostats on the other 3 units. I set them to 78 degrees Fahrenheit. I set the thermostat on this unit to 65, forcing number 1 to run. Now, I want you to zoom in so that you can see this. This is the sight glass, and it's supposed to be a liquid line sight glass, and you are not supposed to be seeing those bubbles. Bubbles indicate a loss of charge. Can you see that on the camera?
Yeah, just put your flashlight on top because a little higher up there.
Okay, so that's the bubbles in the sight glass. Now, another thing that we did was we put a thermometer coming into the coil and out of the coil to see how efficient it was. The other unit was 15 degrees delta T. This one is an 8-degree delta T, indicating it is not working that hard. We know that the amperage is supposed to be 8.8, so I'm going to go ahead and check the amperage right now. I got the disconnect opened up right here, and I'm going to go to amperage, and on phase 1, that's 6 amps, and I can go up to 8.8, so it's not working very hard. Let me go ahead and get phase B and C. Phase B is 7 amps. And phase C is 7.15. So it is working, but we may put manifold gauges on this yet. I'm going to go ahead and go inside, and I'm going to go and check the evaporator and see how it's working right now. Okay, so the last time I left you, I was telling you that I felt pretty confident that this unit had a leak. So at that point in time, I shut the unit off, I opened everything up, and I started using my leak detector. Now for my leak detector, what I use is this tool right here. It's called a Halogen H10. Let me zoom in on that for you. And it's supposed to be a very highly rated leak detector, and I'll show you how I use that. I also came in and had some previous, I had 2 leaks on this unit in the past, and I thought possibly that the welding, the brazing that was done in order to seal up those leaks in the past was the leak. So I started there. So let me show you inside the unit and then show you what's happening here. Now I'm just illustrating that. I'm showing you how I've got plastic over this unit. I had to put plastic over it because there was too much airflow and I wasn't picking anything up, and I felt pretty confident the leak was coming from the condensing section. So I'm going to take you over inside the condenser here. Alright, now it's a little dark. Hang on, let me get my flashlight. Okay, right here on the compressor you can see a previous leak, and I doused that thing with bubbles and was trying to find it, thinking that the leak was going to be right there on the compressor, and it was not there. So I just, with the plastic surrounding the condenser, I just went and checked the whole thing, and this section over here looks pretty rusted as well. I thought possibly, hang on, let me show it to you. It's just hard for me to get everything together here. I thought that it was right there, but nope, no leak right there. Everything was good. Everything was good here. And there was also one other leak here, and let me show you that. Previous leak. Alright, there was also a leak right here. It's a little hard to tell. I can't get it really on the camera, but there was also a tube leak right there that was repaired. Okay, so the condenser was fine. So what I did was I just took the Halogen H10 leak detector, which let me show you how that operates. Alright, here's the halogen H10. You turn it on right here, and you adjust the sensitivity. Depending upon what refrigerant you're dealing with will determine what selector switch you have. Now the refrigerant that I'm dealing with here is R22, so the selector switch is over here to the right. I'll leave the sensitivity right there. So normally what I do is I go around my pipes and I'm searching for, I'm waiting for this thing to start buzzing on me, telling me, okay, I got a leak right there. And I didn't, alright, the light shut off on me, I had to restart. So anyways, I took my halogen H10, and these here are the suction line and the liquid line right here. And I just went around and kept waiting for this thing to sound off. And then I came up here to the liquid line sight glass, and I started getting that. Now you'll notice how that is really lighting off. Once that lit off like that, which kind of gives me the general vicinity of where the leak is, then what I do is I take a product, in this case it's this Brush On Blue, and I also have this product right here, which is just Big Blue in a spray bottle. So what I'll do is just take this swab, put it in there, and I'll show you what I'm going to observe. Put it here on the top, and do you see that? It is leaking really good right there. You can clearly see that I have got a leak coming from this sight glass. So the first thing that I did was use the halogen H10 to pinpoint it. Then you use the soap bubbles here in case you got something else leaking. Check everything else out right here. And check everything around here on the bottom. And it is very evident that the only problem that I have is right here to right here. So I'm going to try to seal that up. I'll try to tighten that down. I might have to remove the charge and then replace that seal and then go for that. Or I might even have to replace the whole sight glass, so we'll see in a second. Alright, so there's the sight glass. I'm just going to take an adjustable wrench here and see if that's loose. Indeed, that was slightly loose. I was able to get a little bit out of that. Let me go ahead and put some Big Blue on it and see what happens. Not getting any leak at this time. Let me just verify that that's nice and tight. It didn't move much. Alright, let's go ahead and take the halogen H10 on it. Alright, that is no longer leaking. That leak appears to be now fixed. I'll just test it one more time. It was just loose. Alright. As long as I'm here, I've got another sight glass here. Oh, but this one is non-adjustable. I was just talking about that sight glass right there, but this one doesn't have an adjustment on it like this one does. It doesn't have a removable face on it. So anyways, I was just basically that's all I need to do. Let me pan back. Alright, so basically I feel pretty confident that I found the leak and that the leak is now off. I'll just put my manifold gauges on here, charge this unit up, and get it to the proper proper amount of charge, and I'll show you that when I do that. I'm back at this unit. I'm getting ready to put gauges on right here. I've set the thermostat to 65 degrees Fahrenheit, and I've already turned on the indoor unit. Once we hit the disconnect, this unit is going to light off and it's going to stay on because it's at 65. There's 3 other units here, but I set those thermostats to 77 degrees Fahrenheit, causing them to only work if the room is starting to get too hot. So basically, we're going to turn the disconnect on, and then we're going to put these gauges on. Okay, so here we are, and we're going to attach these manifold gauges, HVAC manifold gauges, to this air conditioning unit right now. This is my set of gauges here. It's a 4-valve setup called the Brute. It is kind of heavy, but I like the way that it works, and I've got 2 sight glasses. I got 1 sight glass on my regular 1/4-inch hose, and there's a built-in sight glass here, and then there's a 3/8 hose when I go and pull a vacuum on a unit. I leave it off except when I'm pulling a vacuum on a unit. Okay, so I'm just going to support this right here, and now you'll see that I got pressure on my gauges right now, 50 pounds and 50 pounds. That's because I've got low loss fittings right here on the low side and on the high side. And these are currently charged with R22. The refrigerant in the unit that I'm working on is R22. So this is perfect. I do not need to bleed the refrigerant out of this line, and it'll be really good for this setup. So I'm just going to support my gauges here, remove the high side and low side. Okay, so I've got my lines here. Now on a lot of people's gauges or hoses, the lines are color-coded, where the low side is blue and the hose is blue, and the high side is red and the hose is red. Mine are all just yellow, so I have to pay attention to where I'm connecting onto. Right here is my condenser, and right here is the liquid line coming out of the condenser, and this is the suction line going back to the compressor. So I'm going to remove the caps off the Schrader valve, and you always want to look inside your caps to make sure that if it's the O-ring type, that your O-rings are in there. I'm going to show that to you on camera. There's an O-ring in those caps, so I'm always verifying that that's happening, okay? So these caps are fine. I'm just going to put them there. Now, one other thing that I'm going to notice is that there is a Schrader valve here and on the high side. So that's telling me that once I connect on, I should be in the system, and I should not have to change these service valves right here. I will confirm that when I connect on. So the first one I'll connect will be the low side, which is the blue. So what I'm going to do is I'm going to get this ready. Now there's a conduit in my way, so I just have to put a little pressure on that. Alright, just about on. Now, what I want you to focus on is this low side gauge. When I connect on, you should see gauge deflection. You see that? That's telling me that I'm in the system right now. So I am in the low side, and it's pulling a very low 30 pounds. For an R22 system, that's way too low. Now, for the high side gauge. Okay, I'm going to bring that over here. And now watch the deflection on the high side gauge. Okay, we're about 200, which is actually not bad. And that is how you put manifold gauges on an HVAC unit. Okay, so now that I got my gauges on unit number 1 for the first time, I was filling out my checklist before I put my gauges on. I knew that there was a problem. Now that I put my gauges on, I'm going to write down the suction discharge, and I'm going to get some more information here just to fill out my checklist. I'll write down the evaporator temperature, the high side pressure, the corresponding temperatures, and all of that. Because I need to add refrigerant to this system, I want to start off with a baseline, as you will. So when I add the refrigerant in, I can see where I went from and where I'm going to. Alright, so now what we want to do is I got my digital scale, I got my gauges attached to the unit. This unit's low on refrigerant, I need to add. I've already taken all my readings and I filled out my clipboard so I have all my baseline readings. I'm going to turn the scale on, let that zero out. While that's zeroing out, I'm going to get my jug of R22 ready. Alright, so that's zeroed out nicely. Now I want to use the, by the way, I'm making sure all my valves on my manifold gauges are closed and tight. And now I'm going to remove the line right here, the 1/4-inch line for the yellow service line. Alright, so now I'm going to attach that to my 22 jug. Hang on. There it is. Gotta get the threads on just right. Now what I'm going to do is I'm going to open this valve, but at the same time, this is cracked. So when I open this, I'm going to purge the air out of this line and wait till it comes out here, like that, and then shut. That's it. That's all it takes just to purge the air out. Now I'm going to open this jug up 100%, and I'm going to turn this upside down. Alright, I want to make sure that this hose and this is all running freely so that this scale is accurately measuring this, the weight of this unit right here. So let me let that settle out. Now what I do, another thing that I do, is I take the date and I'll write it down right here on the top. 2/14/14. This is UPS AC number 1. And now I'll write down start. So I'm just going to get a baseline here of what I started with. 18.69 pounds. Okay, now that I've got a baseline here, what I'm going to do is I'm going to zero out the scale again. Okay, so now I'm zeroed out. So now, when I add the refrigerant, I'll be able to know exactly how many pounds I'm adding in. I'm guessing I need about 4 to 5 pounds of refrigerant in this system right now to get it to where I want it to be. All purged out right here. The compressor's running, and I can go ahead and put my meter on the compressor, and I can see what the compressor is doing for amperage. Right now it's pulling 6 amps on the condensing unit, and I go up to 8.4. Now, I inverted the jug, meaning I'm going to be adding liquid in here. When you add liquid, you have to be careful. It has to go in super slow. Otherwise, you can slug the compressor with liquid refrigerant. I don't want to do that. Let me show you how I prevent that. Now, alright. So what I'm going to do is I'm going to crack open this one. And I'm going to crack open this one here, adding refrigerant into the system. Right now I've got 35 pounds. I do not want more than a 10-pound differential on the low side gauge when I do this. It kind of jumps around, so you got to be careful. So there we go. I started out with 34, there's about 45 pounds on there now. jumps around a little bit, so you gotta kind of go slow. Now you can see here on the sight glass that refrigerant is going in. I've got two sight glasses here to tell me what's happening, and I can hear that the compressor is okay. I can see the amperage on the compressor. I can see that it's only 6.2. Everything is fine, and I'm monitoring how much refrigerant is going in the system. So right now it's just 0.3 pounds, so it's very little. And what I'm going to do is I'm going to keep going in this state until this pressure starts coming up to a more reasonable pressure. The suction pressure should be really not ever lower than 55 psi on an R22 system. So I'm just going to keep adding this in slowly and doing that. One other note that I can make here is that I'm wearing safety glasses and I've got some gloves on for some personal protection equipment. I'm not working with refrigerant directly, and in case some refrigerant was to leak out of a fitting or something, I've got some eye protection. You should always have this on when you work with refrigerant and putting gauges on the unit and so forth. So this is kind of a slow, boring step, so what we're going to do is cut the film for now. We're going to continue adding until we start seeing some good numbers, and then we'll revisit this. Okay, we just want to give you an update. So far we are 2.8 pounds into the unit right now. The suction pressure, I'm going to go ahead and shut the blue valve off for now, so we're not adding refrigerant. The pressure now is at 50 pounds. We started like about 30, 35. Discharge is at 225. The sight glass here, liquid line sight glass, still has bubbles in it. So we're still low on charge. I'm going to continue to add refrigerant at this time. I just wanted to give you an update, and that's it for now. Okay, so we're done adding the refrigerant into this package unit number 1. Now the findings that I got here, the readings on the gauge, let me show them to you. We'll do a zoom in on that. Okay, on the low pressure gauge, it's reading 50 pounds, which is lower than normal. And on the high pressure gauge, it's reading about 220. So I've added into the system, I've added 6.8 pounds of R22. The bubbles are gone out of the sight glass. I filled out my evaluation sheet, and basically right now what I'm getting is on the evaporator, the inlet temperature is, the air temperature is 73 degrees, and the outlet temperature is 55 degrees. So the air delivering out of the evap coil right now is 55 degrees supply air temperature. When we started, it was 58. The delta T across the evaporator coil is currently 18 degrees. When we first started, it was at 15 degrees. The condenser coil, when we first started, we were getting an 8-degree split across this condenser coil. Right now, we're getting a 17-degree split across this condenser coil. No bubbles in the sight glass indicates that we have plenty of liquid refrigerant going to the metering device. So I'm not necessarily hesitant wanting to add more refrigerant. The thing that I'm not exactly 100% happy with is that low side pressure of 50 pounds. Now, with the low side pressure of 50 pounds, my concern is that my evap coil is running too cold and I'm going to ice up. I took an actual low temperature of the suction line coming out of the evap coil, and that number is 40 degrees Fahrenheit, 40. It's above 32 degrees. I am not going to ice up my evaporator coil. So even though I've got a lower pressure than I really would normally be seeing, I'm not necessarily going to change anything. I also took an amp drawer on the unit. The amps are actually the same, 7.3 amps, and I can go up to 8.8 amps. The compressor is not stressed. So we are completely done with this unit, for the annual service. All that we have to do is I'm going to take the gauges off, and I'm going to, once everything's done, we'll wash down this coil. But basically that was the process. Okay, I want to get my gauges off of the unit. I'm done adding refrigerant into the unit. So when I was adding refrigerant in the liquid state. So this is what I'm going to do. I'm going to spin this around. This valve is still open, but now it's going to give me a little bit of, all right, what I'm going to do is I'm going to shut the tank off, but I still have liquid in this line. I want to get all that liquid into the unit. So I'm going to open this up and open up the low side, and I'm going to let that purge into the to the low side to get all this out. I'll also, what I'll do is I'll open this up and I'll put just a little bit of vapor in here, just making sure that I get everything in. Then I'll shut it off from the tank. Okay. Now, I'm done with the tank. I can pull this off. I'm going to go ahead and pull that off, and I'm completely done with the service on the tank. And I got all that liquid into the unit. Now, the next thing that I want to do is I want to remove my high side gauge. So the high side gauge is back here. Not the high side gauge, but the high side port. I got low loss fittings, so I really didn't lose anything, but I got a little bit of high pressure here. So what I'm going to do, so let me just cap that in the back. Okay. Now, you see the pressure inside these gauges? I'm going to open up the blue and I'm going to open up the red. What that does is it's going to equalize the pressures into the suction. Notice how the gauges are equalizing. So I'm just going to equalize the pressure to the suction pressure on the low side and the high side. Then I'm going to shut these off. Now the last thing that I need to remove is my low side connection. Okay, the low side connection is out. Let me cap that on the back. And then the last thing that I'm going to do is put my caps back on. And when you do the caps, of course you want to make sure that your O-ring is inside. So I got a good O-ring here. I'm going to go ahead and put that on the suction side. And I'm going to do the same thing for the high side. And that's how you remove gauges from the unit. Okay, one other note that I forgot to mention was what the superheat level was on unit number 1. This is unit for the leak. We found the leak at the liquid line sight glass, tightened it, checked it, no leak. We added refrigerant. We added 6.8 pounds of R22. Now the superheat level when we started was 54 degrees Fahrenheit. At the end it was 15 degrees Fahrenheit. Much better number. Still could be considered slightly high, but considering that I had a full sight glass, I didn't want to push any more refrigerant into the unit. So basically that was it, just as the wrap up. Superheat level. How do you get the superheat? This was a fixed metering device, so to check the charge on a fixed metering device, you do want to use the superheat method. So in order to get the superheat, the first thing I'm going to do is I've got my manifold gauges on there. The low side pressure was 49 psi. The corresponding temperature to the saturation temperature is 25 degrees Fahrenheit. The actual low temperature, this is the temperature of the suction line coming out of the evaporator, was 40 degrees Fahrenheit. You take 40 and you subtract 25 from that, that gives you your superheat level of 15 degrees, which is a reasonable number. So anyways, I just wanted to, I don't think I said what that superheat level was before or anything like that. That's a very important number because you are charging on a fixed metering device is based off of that number. But basically that's it. And the The rest of the units are pretty much the same as you've already seen, so we're just going to continue doing annuals across the board with the same process that you saw. And that's it. All right, so we checked the other air conditioning units. All the other air conditioning units, after we cleaned all the coils and everything, except for the condenser coils, which we're going to do right now with the garden hose, were giving us a 15-degree delta T across both the evaporator coil and the condenser coil. So everything looked in line, so I didn't even put manifold gauges on them. We're going to go ahead and start washing these coils down right now. Basically, it's just taking a garden hose like this and just going around the entire unit, kind of like this. I'll do this first one here so that you can see it. This is why we waited until the end, because we didn't want to walk in all this water. But basically, that's it. Thank you for watching the video. I hope you enjoyed it. If you could do me two things. If you liked the video, if you could please hit the like button down below at the bottom of the video on the left-hand side. I'd like to. That would be nice. And also the second item, if you could leave a comment. I love to read the comments that people leave behind, whether they like the video or didn't like the video, or if they need some help or anything like that. The videos that I create are generally created for the people who work in commercial office buildings in the maintenance department, people that specialize in mechanical, electrical, and plumbing, although we do touch other things like roofing and other trades, drywall, painting, and so forth. But if you have any questions or anything like that, I also would like to share with you my website that I have, which is at kencogliano@wix.com/Ken Training. I am going to provide a link at the end of this segment, so this way if you want to click on that, you can go directly to my website. You can also check out all my videos there, as well as there's a section that you can send me a personal email if you wanted to discuss something that you're working on or anything like that. Thanks again, and I hope you have enjoyed the video that you were watching.